Okay, everybody. My name is Kurt Rasmussen. I'm with Bentley Systems. I've been with Bentley about 5 years. Prior to this, I was a CAD manager for about 20 years. And during this process, a lot of my work that I started with was photogrammetry from airborne, also LiDAR, which then brought me into terrestrial LiDAR, which then I focused about 16 years dealing with just LiDAR. Now, for the last 5 years, I've been doing the combination of LiDAR and photogrammetry. In today's Tech Talk, we're going to learn how to consume reality meshes in your existing design, construction, operation, and inspection workflows. We'll also see how to create reality meshes with context capture using photos and point clouds. We now have that ability. And then I'm going to show you how to edit reality meshes using ContextCapture Editor. And finally, we'll wrap up showing the mobile app and our new cloud service applications, which include ProjectWise context sharing. So first on the agenda, how we consume these reality meshes in our existing design. Reality modeling can be applied to all phases of an asset lifecycle. For example, in design phase, as well as construction and operations. When it comes to the design phase, we use these reality models for our existing conditions. It gives us a nice base to start from, better than just an aerial image that's draped over some terrain. We can create a real 3D model from it. In this example, we flew this area, create a 3D mesh of it, which we're going to use for our existing conditions. And there we're going to extract ground. So we circle the area of our project. This is the area of reference that we need to tie into existing conditions. Now right now we're using Open Roads Concept Station, the Connect Edition, and we're viewing our reality mesh that was created with Context Capture. Here's the bare ground. We see that it created terrain underneath the bridge, and we're able to edit those vertices if needed. Next, we can come in, lay out our proposed roadway. Look at our profile of it compared with existing conditions. Once again, that terrain is created from the mesh that we used. We adjust our proposed roadway to meet existing conditions. And quickly adjust our length of curb. Just this fast, we're able to add a bridge. And we see it creates a 3D model. Now, this is really live. It is this fast that you could just move things around and add them very quickly. Since the design work is done in 3D, we can quickly bring this into LumenRT. Here we're drawing in trees. Very quickly, just to use a paintbrush, this is live. And then quickly lay out cars. Now this can be done on the MicroStation end. If you use the Viz simulator, you could put in your cars that way or come right into LumenRT and quickly lay them out. It's a lot easier to go in front of a planning board with a video like this to show how the conditions are going to look after the construction, as opposed to just doing 2D drawings and putting them up on an easel and trying to explain what your proposed design is going to look like. So when we talk about construction, pretty much people want to watch the change detection. As construction's going, people have a lot of investment in this. They want to make sure that it's on schedule and going. So weekly, we could fly a drone around, take photos, create 3D mesh models of it on a weekly basis and archive it in that way. This is a real project that was in Hong Kong. We see here's the flight path that they're looking to lay out. So they're going to do some orbiting, which will give oblique images, and then they're going to go back and forth for nadir images. Nadir images are going to be straight down. Here we see video from the drone. These are the straight down nadir views that are being taken. And while it's moving around, it's taking incremental pictures, making sure that they have enough overlap to create a 3D model. Here we see the final product. You can see where the photos were taken, so we see our back and forth nadir images as well as the orbits. Now we take this into context capture. We look at the bare earth points. And then the final mesh. In this project, they did this to just check how construction's going on weekly basis. You'll notice the amount of detail that's picked up from these photographs. And then we could look at this and see how it's progressed over time. Many of these projects are billing as the project's going on, so they need to show the work that's being done. It's a lot better to show a 3D model, which is the real conditions, as opposed to just a set of plans. We then can bring this into MicroStation and do some cut fill volume calculations. This is looking at the 2 times, and we could do a report. Now we look at what we can digest this model into LumenRT. This product adds realism, environment, movement, animation, as well as fly-throughs very quickly. So we can see here the mesh, what it looks like. We could start showing what the proposed design is going to look like as it's progressing. So we see how this has been used for construction. It's very helpful to look at the final project as it's going. Make sure that your design matches what your existing conditions are during construction. So let's talk about operations. We now have this mesh model of existing conditions, but sites need to operate and we need to keep track of that. We could use these reality models to train new staff for existing assets and operation conditions. We use these same models for visual operations, allowing owner-operators to easily document existing conditions. The 3D model we could link to AssetWise or any other asset management system that you're using, and we can visually navigate through the model, query information as you need. Using this reality modeling, we could speed up the process of the inspection and offer higher quality, more repeatable documentation for the inspection process. Here we see this is for a tower. And here we see the finished results in MicroStation, where we're able to look at this 3D model very closely. Here's another case where we used a combination of drone and handheld camera down at ground level. You see, by combining that, we're able to really get high accuracy down at the equipment where we need it. This final mesh allows for a virtual walkthrough where somebody could walk through to inspect parts of the equipment and gather more information as needed. Here we see a pump. Now, classification, you may have heard of the term classification with point clouds, which is separating it. Very simple way. We do the same thing with meshes. This allows us to run a query. So we could do a search for equipment that contains pump. And we see right away it highlights them all for us. So now we know the areas that we need to go look at deeper. Now we're also able to link back to the original photos that were used, photo navigation. This gives you more detail if you need to look at the mesh and you really need to inspect it and see a lot more detail to it. We then can query in, look at the management software that has all the data attached to that location. Could also clip that out so that we're able to isolate that to inspect it a little further. We're also able to mask that. So if we wanted to remove this pump, and maybe we have a proposed pump that we're going to be adding in place, we could see how this fits in. So during inspection, you're going to want to look at your original high resolution photos. We have the ability to link back to the photos that were taken to create this mesh. There we see all the locations of the photos, and as you pick on it, you can see the perspective of that photo. When you find an area of the photo that picks up the area that you're working with, you're able to just go directly to your photo, zoom in, and see the high-res detail that you need to. You could align to the photo too. So this is where the photo was taken, but you're seeing that same perspective of the mesh. This process could be used for all your inspection needs, whether you're doing bridge inspections, cell towers, or plant stations. Now, this is something that we didn't have in the original agenda, but I wanted to throw it in. We have a trial version and a sample data set, which I'm going to be walking you through right now. If you go to the trial page, we see here that we have some information there for downloading a quick start guide. There's also some information at the bottom of what services are coming soon. I'm going to go and start download trial. So for any of our users on the call that do not have a copy of this, you could use this link to go. If you're logged in already, it'll bring you right to this download now page. Otherwise, you'll have to put in your Bentley user credentials. Now, as that's downloading, I'm using Chrome here. We see it's less than 2 minutes now. This whole process takes pretty much less than 2 minutes on a standard computer with standard internet connection speed. And we'll also notice up here we have Visit Bentley Communities for help in getting started. It's a great way to link with Bentley colleagues as well as other people in the industry that might be dealing with the same questions that you're coming up with. Now I can open that. It opens up the trial. I'm going to say install, say yes. I have this on my other screen. I recommend you read the end user license agreement fully, accept, and choose next. And finish. Now I have it checked on to launch the settings window. One thing I want to point out here, we have the system information, and in the lower right there's benchmark, and I'm at 80.4 on a laptop here. You could start the benchmark and see where your computer rates. It will change depending on what's running. I'm doing the recording right now, so it's also taking up some of my graphics. So in the first tab, you're going to see here, download the quick start guide. And we see this document has a lot of valuable information about hardware recommendations, the icons as they're installed, which I just covered. Here's the procedure for downloading the data set that I just showed, that I will be showing you. We've installed the software. Next step would be to gather the data set. So here our middle option is download dataset and data acquisition guide. We see once again this is less than a minute for the whole data set. Now this data set has a barn in there which will be photographs. It also has an area of a train station which will have LiDAR data as well. So if you're looking to merge photos and LiDAR, there is a sample data set for you there. Now this is a zip file. You just want to unzip this to a location where you keep your data sets. After we open it here, we do see there's an acquisition guide, which I'll open here. This goes into a lot of detail, given real-world examples, procedures, overlap recommendations. You then go back to this document. It talks about context capture, gives you other examples, things you should avoid. A lot of this is covered in the acquisition guide. This is a shorter version just to get you started very quickly. At this point, we're going to the workflow for importing the barn. So I'm going to refer to that document on my other screen now. We see when we open ContextCapture here, the main screen starts. Now I'm going to cover how to take your photos and make a 3D mesh model from that. Now you can point to an entire directory. That's what I recommend doing. All those barn photos are in one folder, so you could just point to the directory. As we click here, we see these images in the right. If I go back to my General tab, we choose Submit Arrow Triangulation. Now I'm going to use default settings here. You need to start your engine, which is a separate icon. Keeps track of the jobs running. This is live, so this file is very small. It's about 16 photos, and it was able to process that fast. Now these are the key points that were done for arrow triangulation. You look at this to make sure that it looks roughly of your scene, and then I'm going to create a new reconstruction. Now if we go to spatial framework, this is where you could trim your model down if needed. In this case, I don't want to trim it down, but for this demonstration, I'm going to cut this into 4 tiles. Now it's not needed because this is a very small scene, but for me to follow up after this to do some editing, I'm going to show you how we can cut this into pieces. So I'm going to set it to 20 units. This will break this one barn into 4 tiles. Now we see here by default it's going to 3MX. We have other options. You see some are grayed out because this is not spatially located. We see the 4 tiles. Now I'm going to produce all 4 tiles. Now this process doesn't take very long. For this actual scene, it took about 10 minutes, so I recorded this to speed it up. We jump ahead here. We see that 3 tiles are done and the 4th is being worked on. But what I want to show you is as the tiles are created, you're able to start viewing them. So I can go in and see how it's working as the tiles are being formed. If I go back to my General tab, look at the production, I'm at 56%. If we just wait for that final one to finish, 84%, and it's complete now. So if we look now, the whole model is completed. There's a piece of rope here tied to the barn that I'm going to want to remove from the scene. So I'm going to submit a new production. Now this is live time. It takes 20% of the entire first process. So I already made my mesh, took about 10 minutes. This process here should take less than a minute. Now I'm making a DGN format. I'm sending this out for retouch. Now I don't want to do every tile, so I can say select from a 3D view. So we see here is my barn cut into the 4 tiles. So I'm going to find the area, which I see back here is where the rope is. So I make sure I got the right quadrant. So now as simply as clicking on that is going to select that tile. Just make sure I have the right tile. There we go. So we see it automatically check that for us in our box. We can hit submit. Since it's only one tile, it's very fast. So as I said, it's 20% of the time, but plus we're only doing 1/4 of it. So that was probably 10 seconds. So I can right click on this and say open the output directory. This way I don't have to go browsing through my folders to look for it. Makes it a lot easier. Now I'm just going to right click on my DGN file and I'm going to say open with ContextCapture Editor. Now by default it opens showing all the windows. I'm going to close them so we could focus on the main one. I'm looking in a wireframe mode. It makes it real easy for me to see where this rope is sticking out. I select the mesh that I want to edit, and I'm just going to throw a quick fence around this just to grab it. And then left click and that'll remove that. I see there's a little more, so I want to refine this a little better. Now we can change this back to an illustration mode so we'll see the material on it. And we see that the rope is gone. And just that simply, we edited this. It is the DGN file, so since we're in DGN, it automatically saves. So I'm just going to close this. No need to do anything further there. Now when we go back, I'm going to reference a 3D model. So I'm going to import my retouch. Now I didn't touch the JPEG or the texture in this, so I only need to deal with the mesh. And we point to that tile, select the folder, and very simply just say import retouches. That fast, it connected to that file. And we now see that there's a yellow mark in front, the exclamation. It says one job requiring update. So I submit the update, say OK. This is actual time. It's done 75% because 3 tiles had no changes. It's doing the final tile. And this should be done in just a few seconds. Okay. Now let's take a look at the results. Remember, this is the back corner that had the rope connected. We now see it's completely gone. This method could be used for a lot of extra things that may come into your mesh. There's people. Actuality, our software will remove people and cars as long as they're moving. But if they're not moving, they will be modeled, so you may want to go in and remove them from the mesh. And finally, on our agenda, I'd like to talk about how we use the mobile app and our cloud service applications, including our context share. So with our mobile app, we also have a desktop version where you could process your photos, send it up to the cloud. The data is then processed and moves over to the ProjectWise Context Share, which then your whole team is able to digest that, whether it's through a web browser, their mobile device, or their desktop application. Here we see the mobile device. It's very easy. Create a new project. We're going to give it a name. This is for a bridge inspection. Now, if you already have a Connect project, you can link this to it. That'll bring your data into ProjectWise Context Share. And this way, everybody on the team has access to it. Now, you can add photos either by taking photos or going to your photo library. Me personally, I like to use my cell phone or mobile phone to take the photos and keep them in my phone and then manually browse to them. This way, if I want to go back to use them again for anything else, I have access to them. Now, in this case, you see that there is a tape measure in this scene for the bridge. That'll allow us to scale this correctly so that we can line it up with our other data that we have in the CAD environment. See, the photos are then brought into your mobile device. We say submit. We can adjust the mesh quality too. So if you're just looking for a rough layout of where things are located, you could use a lower quality mesh. It'll be a lot faster for you. Or you can go high resolution if you need to see the cracks. Now you'll get an email which will let you know that it's ready. Here we're viewing through the web browser. So we see some failure here. I'm going to search for my project to bring this into MicroStation. So if we zoom closer on this crack, we also have our CAD model attached to this as well. Since we scaled this, we could measure. So here we can see our CAD file that has the rebar that was designed for this. We could compare this and see how deep this crack is and how much effect that it's going to have. Here's our context capture service. Quickly, we could just grab the photos that you have, once again, if you have them associated to a Connect project. It's very intuitive, not many things for you to do. You point to your photos, process it, this will go up to the cloud. Once again, you receive an email letting you know it's complete. Log in with your Bentley credentials. And in this case, we want to save it down to our local drive. And this brings us to the mesh that you saw before that we created. So in this Tech Talk today, we learned how to consume the reality meshes in your existing design, construction, operation, and inspection workflows. We also covered how to create the context capture reality mesh using photos, as well as point clouds, which is in the data set that you'd be provided. I talked about how to edit that reality mesh using ContextCapture Editor. And we talked about the mobile application for the cloud services. Here's the link if you want to download the trial version. It's www.bentley.com. /ContextCapture trial. If you need more information, you can always go to bentley.com/ContextCapture.